So those of you guys who are coming in, this is the GitHub repository for everything that we'll be working on. So even after the tutorial, the notebooks, I'll publish them all here. What I do want you guys to do is if you can go to that link that's highlighted up here, and if you don't know your way around GitHub, you can click this green button here and click download zip, and that will at least download everything. And the most important part about that is because the data sets that we'll be working with are all stored in this repository. So if you want to follow along, at least you can follow along that way. So I'll just keep talking a little bit about setting up. So when you download this, if you downloaded, I'll assume that you downloaded the zip version of it, and I'm not going to assume that everyone in the room knows Git. Unzip it somewhere that's convenient, so the desktop is probably a useful place, at least for the tutorial. For those of you on Windows and Macs, I sort of assume that you're running the Anaconda distribution of Python. And so if you open up the Anaconda Navigator, if this is the first time you're opening it, it might take a while, take a little bit of time, but there is a button in there that says Jupyter Notebook or Jupyter Lab. And once you click that, a browser should open up. What I am going to show is a little bit different because this is a Linux machine. But let me just hide all this random other stuff before something I regret shows up on the screen. All right, so if you use the Anaconda, the Navigator, and you click on Jupyter Lab or Jupyter Hub, eventually you might get a screen like this if you click Jupyter Hub, sorry, Jupyter Notebook. If you want, there is a new-ish version that you can play with called Jupyter Lab. I'll probably end up using Jupyter Lab for this tutorial. And Jupyter Lab is, you can think of it as like the next iteration of the notebook system. It's pretty handy because you'll have a lot more convenient access to everything, so you can browse your files right away. What's also really cool is CSV files can also be rendered as spreadsheets in Jupyter Lab, which is really useful if you're just playing around with data. What's also really useful is you can have multiple notebooks open at the same time, and you can have like 2 views of the same thing, which is like really useful. That was like one of the things people were complaining about all the time. And so Jupyter Lab, if you haven't played with that yet, I would highly suggest looking into it. So hopefully everyone has that up and running. And totally just realized in this whole chaos, I forgot to pull up my notes for the whole course. For those of you guys who have questions, feel free to raise your hand. Someone will run to you with a microphone. You can totally interrupt in the middle. I don't really care too much about that. And sorry, give me 1 second. I am pulling up my notes. All right. Oh, that's not helpful. Render the website. All right, that works. All right, so this is a very introductory tutorial. So if you've never worked with pandas before or worked with tabular data in Python, this is generally the target audience that I'm aiming for. The main difference about this one is I'll skip over a lot of stuff and get right to the actual tidying data portion of it, which I found to be that was the reason why I switched over to using Python or R to do analysis, just because doing these data manipulations was just sort of magical for me. So that's sort of the general pace that we'll go in. If you've seen other tutorials that I've given, you'll notice that like I pretty much jump from like chapter 1 to like chapter 6, but we'll cover holes along the way, so don't worry too much about it. So hopefully you guys have the datasets downloaded and you have this notebook system open, and we'll sort of just live code along and just talk through the commands as I go through them. So Python comes with a bunch of libraries, and by default, just to make things faster to load, they don't load up everything at one go. So we have to import our, oops, let me make this bigger. So we have to import libraries. So the library we're going to use is called Pandas, and this is our library for reading in tabular data. And so if we want, we can now use Pandas. They have a special function in there called read CSV to read in CSV files. So we can assign what we load in to a variable. So I'll call it df or Dataframe. And in Python, when you load in a library and you want to call a function within a library, you use this dot notation. So we're saying in this Pandas library, we want to use a really specific function out of it. And the function we want to use is called read CSV. And if you're wondering how I got that thing to pop up, you hit the tab key and it will do that auto complete for you. So in read CSV, if you hit shift tab in the notebook, it will pull up the function signature for you. And the first thing that it will take is the file path or buffer. So this is pointing to the file path or file that we want to use. I forgot. I need to do one more important thing. If you're in the Jupyter notebook system, right now I am in the data folder. So you saw before that we were originally here, I clicked data, and then I created a new notebook in here, right? So that's what I ended up doing. So when I hit like /, meaning like look in my current directory and hit tab, all the data sets that I have are in there. And in the next notebook, I'll show you what happens when you move your notebook into another folder. So the first data set we're going to look at is called gapminder.tsv. And you can look by the extension that this is a tab-separated file, not comma-separated. So we actually need to give read CSV a different parameter called sep equals /t, so \t. And this is how we tell Pandas, hey, like by default you read CSV files or comment delineated files, but in this example, we actually have a tab delineated file. So this data frame thing in Python is an object, so df. And if we want, we can print out all of df, and it'll just give us the entire data set dumped out to the screen. But one really convenient way is this method called head. So we say df.head with round brackets, it'll just give us the first 5 rows. And when you're loading in data sets for the first time, this is really useful because you just really want to make sure that like your column, your column names got loaded properly. Sometimes data sets like the first row is like an empty column, in which case like it might not load properly, or maybe you don't have columns in your data set at all, and Pandas will by default treat the first row as like column name, so you might end up with something wonky. So you always want to look at like head just to make sure that everything is loaded properly. So if we look at our data set, a data frame in Pandas really has 3 different components. There's the column names on the top, there is this index on the left, so in this case the index is really the row name, the row number. And then there's like the body of the data frame. And if you ever so you can access those 3 components however you want. So we could say df.columns, and that will give us just the columns of our data set. You'll notice that columns does not have round brackets. It's just an attribute of the data frame. It's not really like a function that's being called. If we want to access the quote-unquote row names, it's df.index. And that's how you get the index portion. So if you end up going down Pandas and you work with a lot of time series data, you'll end up setting like the date time as the index, so you can access your data set, access different rows by the time of day that way. And then in the middle right here, like the actual body of our data frame, that's called the values. And so this is one way if you need like, hey, I'm trying to take this data frame object and pump it into this other library, and this other library like doesn't understand what a data frame is, and it works with like the NumPy arrays. This is how you essentially get like the NumPy array version of your data set, right? So It used to be you had to do this when you were working with scikit-learn all the time, but they sort of handled the ability to work with Pandas data frame objects. But occasionally, especially if you work with Numba, that assumes that everything's a NumPy array, and so sometimes you will end up having to use .values just to get the NumPy representation of your data set. One other thing when you're working with Python very often is this type function. This is really useful when you're working in Python when you get some weird error and you just want to know why and what the type of your objects are. So you can see here, this is a Pandas data frame object. You see Pandas data frame right here. All right. So what else do you do when you first load up your data set for the first time? Well, there's this attribute called shape, and it gives you the number of rows and columns in your data set. So this data set, this gap mining data set has 1,704 rows and 6 columns. Right? And so if you can imagine you have million rows or hundreds of columns, instead of inspecting each and one of them, this is a quick way to make sure did I get my data properly? If we're reading data from instruments, this stuff usually ends up being really specific. Every time this instrument spits out a data set, it's 300 rows and 5 columns. And this is one way you can check that the instrument didn't dump out a bad data set for you. What ends up happening, sometimes you forget, I forget as well, these attributes like columns, sometimes I'll put columns with round brackets, and you just might forget. And so if you end up doing something like df.shape with round brackets, meaning hey, I'm calling the shape function on the data frame and not just the shape attribute, you'll get an error message, something like this. In this case, it says it's a tuple object, it's not callable because what got returned back is a tuple, so think of that as Python list that you can't change. And so it doesn't know what this as a function does. So that's why you get an error like that. So other stuff that you do. If you don't really have too many columns, one really useful thing is just saying hey, give me the info of this data frame. And this gives you the type on the first row. So this tells us it's a data frame. We have 1,704 rows. And they're labeled 0 to 1,703. So this label is that index that we saw earlier. And then down here in the middle, it gives us all of the columns. So on the left-hand side, it gives us tells us there's 6 columns here. On the left-hand side, the column name. In the center, it gives us the number of non-null objects. So in this case, you can see that hey, we don't have any missing data in our data set. And on the right-hand side, it tells us the type of information stored in that column. So if you see object in Pandas, that means it's a regular string object. But you can see in this data set, we have integers, we have floating point numbers as well. And there's other types in Pandas as well. So if you work with other statistical languages like R, like a factor, you'll see that encoded as a category in Python or in Pandas. All right, so let's actually do something with our data set. Let's start filtering and slicing out our data just to get over the very, very intro of this stuff. So if we just wanted a single column of our data set, we can take our data set, use square brackets. So square brackets is in general how Python will subset objects. And if we wanted, for example, the country column, we can just put in square brackets and the string country, and it'll give us just the country column, right? So what we could do is we can take this and save this to a variable, right? So we can say country data frame is just that command that we just saw before, right? So if we wanted just to look at the first couple of rows instead of all of that, we can also say .head on that. One important thing is if we look at the type of this, if you have a single column in a data frame, what comes back is a series. So you can think of a data frame as a bunch of columns. Each column is a series, right? So that's just how those two words end up working together. And you can think of a series as almost like a NumPy, like a one-dimensional NumPy array, right? So what happens if we want more columns in our data set? Sorry, let's see, this is subset. So sometimes what you want to do is like, hey, I have this giant data set, but I don't care about like all of these other columns. I only care about a subset of these columns. So what you can do in Python is if you're trying to specify by name multiple things, you can put in a Python list. So we have this outer set of square brackets, which is really telling Python, hey, I want to subset something. And then a list in Python is another set of square brackets. So that's why you'll see double square brackets if you're trying to pull out multiple columns at the same time. And so here, if we wanted country, continent, and year, whoops. That's because I spelled it wrong. So if we wanted multiple columns and we're trying to specify it by the actual column names that we want, we can put that in a Python list and then put that list object into how we subset data frames. One other thing to keep in mind, if we do pandas dot double underscore version double underscore, that's how you get the current version of pandas that you're working with. This becomes really important when you start Googling and trying to get help from Stack Overflow, sometimes APIs will break. And hopefully the Stack Overflow answer will give you the version of pandas that they're using, or hopefully there's another solution that is using something more modern. All right, so that's how we subset columns. So what about rows? There's 3 different ways in the actual Python API on how you can subset rows. 2 of them are recommended. 1 of them is deprecated or being deprecated. You'll get a big warning, and not advised. So I'll cover all 3 of them and then just tell you you really only should work with 1 of them. So how do we get specific rows that are our data set? You can see here that there is this index thing that we talked about. Right? So this index plays an important role in how we subset rows because this is going to be how we call a specific row in our data set. So if, for example, we wanted to call this, 2, which is a third row in our data set, but we're trying to reference it by the actual string 2 that you see on the screen, there is a way we can subset data using LOC for essentially location. And if we give it a value, for example, 2, it will look in that index and see hey, what matches this thing called 2, right? It's not really looking at the index, the second index row. It's looking for the thing that matches the symbol 2, right? And this has some consequences. We won't really cover it in this course or in this tutorial, but if you concatenate data, start row binding things together, you can have this situation where this row index is duplicated, and if you say LOC2, you actually get 2 rows back instead of 1, because it's really looking at what is being printed here, which is 2, right? The character 2. So if we wanted to get multiple rows back, just like how we did with columns, we put that set in a Python list. So if we wanted 2 and 0, for example, we'll get a data frame back with 2 and 0 in the order that we want, right? And again, this is LOC, and it's really just doing almost like character matching. I'm looking for the thing called 2. So the other way that we can subset data frames is using something called iloc. So iloc, the I stands for index. So this is where we're actually starting counting from 0 and then saying that is the row that we're trying to get. So if I say iloc2, this is really going, let me just show you what this data set looks like. iloc2 is really going saying I'm getting 0, 1, 2. That is the index position that we want, and that is the row that's getting pulled back out. Right? So there's a subtle difference between the two. In this example, because the index is really the same thing as the row number, it's a little hard to figure out, but you can imagine if you start working with data sets and just combining them, sometimes you want the thing labeled 2, and sometimes you want the actual position in the third or index 2 in your data set. Right? The last way, if you look in the documentation, there's this way to access rows and rows called ix or ix. And here, if you try to do anything in ix or ix, it will give you a where is this? A big giant deprecation warning. And it also says, like, please use LOC or ILOC instead. I don't remember the exact order, but I think Ix sort of works it works as if you're using LOC first, and if it can't do that, then it'll drop down into iloc, right? And so you can see it's kind of ambiguous, and so that's sort of why they're saying, like, hey, don't do this at all. And you might run into old code bases that actually use IX, and when you see it, try to fix it or talk to the guy like, did you mean like the label of the row or the actual index position of the row, right? And they're sort of enforcing your code to be a little bit more readable by saying, like, hey, this thing that's ambiguous, let's just get rid of it. Right. So how do we get multiple rows and columns? Let's say we want to subset our columns and also start filtering by rows. So so you end up using LOC to subset both rows and columns. And under the hood, if you really want to be like really verbose on how you type this stuff, LOC, if you've worked in R, the notation will be really similar. You can have a comma, and there's a portion to the left of the comma and a portion to the right of the comma. How you specify your rows is going to be to the left of the comma. And then how you want to specify or subset your columns is to the right of the comma. So in in Python, if we, for example, just wanted to get all of the columns and keep all of the rows, we can put this slicing notation, this colon, that just says, like, hey, give me everything here. And this just says, hey, give me all of the rows. And then on the right-hand side, if we wanted multiple columns, remember multiple columns we can put in a Python list. We can get all of the rows in our data set and then just filter by columns that way, right? But this notation, it really is pretty silly in this case because we could have just used the double square bracket notation to begin with. But this has advantages because we can now also do, Boolean subsetting of our rows at the same time, right? So what does that look like? Let's say we wanted our data frame, we're basing it off of the index label. And then here, let's say we wanted, year in 1967, right? So how do we specify? We want all the rows where the year is 1967. So we can really say, hey, df, we're taking the year column, and we want to make sure it is 1967, 1967. And then if we wanted the year and population, we can do a filter for all of the rows where our year column is 1967, and then just subset specific columns. All right, any questions so far? That is one more example. We'll do one more example. If you're trying to do this Boolean subsetting and you want to do, for example, multiple conditions or multiple Boolean cases, the trick is you have to wrap each individual statement in a set of round brackets. So let's say we wanted year, that's 1967, and then also df pop greater than, I don't know, what is this, 1, 2, 1 million? That seems kind of low. Maybe this will work. Other cool thing about Python, numbers like 10 or 1,000, let's use 1,000. 1,000, you can actually use as a visual marker this underscore for integers, and it represents the same thing, right? So if you need like the equivalent of a comma to help separate out your numbers, Python sees 1_000, the same thing as 1,000. So again, hopefully it makes your code a little easier to read. So I have these two Boolean cases, and if we wanted both of those to be true, we can use the ampersand and. If you wanted the or, you use this vertical pipe for or. And the reason why the notation ends up looking like this, where you have to use round brackets and then ampersand instead of the regular Python A and D, it's really doing bitwise comparison, and so that's why the code looks like that. All right, cool. So now to the actual portions, because we are now done with the intro. So if you downloaded the datasets or that folder, there is a folder called Notebooks. Hold on. There is a folder called Notebooks, so let's go into the Notebooks folder and then create a new Jupyter notebook in there. So the first notebook, I can rename this, and I'll call this Intro, and then the second one, I will call this Tidy. Right. So the key here is I am now in a different folder from where all the data sets are stored. So that really just has some implications of how we like load or find our data sets. But before we go there, and I'll put this link on the GitHub repo so you guys can find it. But so let's just talk about tidy data and what does it mean when your data set is quote unquote clean, right? And so there's this really nice paper by Hadley Wickham. He comes from the R world, but you know, stuff like this is totally relevant. It's language agnostic. And so what does it mean to have like clean data sets, right? And that's sort of the reason what this paper talks about is like, hey, we have these two data sets defined by table 1 and table 2. And you know, which one is better? Like if we talk about rows and columns, it's really ambiguous, and that's what this paper talks about. Like we actually need like better words for these things, right? And then he also says like, okay, these two things contain the same bit of information, but then here's another version of this data set in table 3, and this is like the actual like tidy or clean version of this data set. And why? So you can imagine, let's say you want to fit a model, a statistical model that is like, you know, some result based off of treatment, right? You can now actually like fit a model that's like result is your Y and treatment is your X, right? Like you have a column for that. Versus, you know, a data set like this, you don't really have like, what is the column that is like my response variable, and then what is the column for my inputs, right? So that's sort of one visual cue to like, well, hey, what does it mean when data is clean? The other thing is like once you get your data really into like a tidy format, so if you're just processing data, this is a pretty good target for like what your final data set should look like. If you get your data set in a format like this, it's pretty easy to convert it to whatever you need, right? So like this version of our data set, it might be good for statistical models, but like if you're trying to like show a table of results, like one of these two forms is probably way better, right? Like for a given person, you can really easily check like treatment A and treatment B. But it's a little harder down here, like, hey, I'm looking for the Jane Doe's A result, and then you have to scroll down to find like Jane Doe B, right? So just different versions of data sets, and they're all, no one version is better than the other. They all serve different purposes, but the key is like once you get your data in a clean or tidy format, it's pretty easy to convert it to one another, and that's what we'll talk about. The formal definition of tidy data, Hadley Wickham talks about in his paper. Each variable forms a column, each observation forms a row, each type of observational unit forms a table. We'll probably really only talk about the first two. So what does it mean for each variable forms a column, each observation forms a row? Let's look at this version up here. You can see that we have a column called name, a column called treatment, a column called result, right? So those are 3 separate variables. That means those are 3 separate potential inputs into a model that we want to define. And then each observation forms a row, right? So for a given person, we have like his or her treatment value and their result. A little bit more down on this paper. Data is messy. It's messy in many, many different ways. But if you also go through the process of like cleaning or tidying your data sets, you'll probably end up going through the first 3 problems, right? And so that's what we'll go through in this tutorial, is just walk through these first 3 things as defined in this paper. And if you do end up reading this paper, we'll actually like work with the exact same data sets except for one of them. You really don't need to read the entire thing. By the time you get to chapter 4 or by the time you get to section 4, that's probably like all you need to know. The rest is really specific to R. But if you just want an understanding of like, hey, what does it mean for data to be like quote unquote good? The first 3 sections is really all you need to read. All right, so we have this other notebook. Let us, start processing and tidying our data. This is a new notebook, so we do have to import our libraries again, one other way you can import libraries is using this as command. So we can say import pandas as pd. And you can see what this allows us to do is we can now, instead of writing pandas dot something, we can now say pd dot. So this is just a way, this is called an alias, and it's just to help you simplify your typing so you don't have to type so much. So the first data set will come from the Pew Research Center, and we'll now use pd.readcsv instead of pandas.readcsv to load our first data set. So in this example, if we look at my folder structure, I have my stuff in the notebooks folder, but the data set is really from this notebook. It's one folder up and down into a data folder, and then that's where my data sets are. Right? So instead of just typing gapminder like we did before, we now have to say two dots that says, hey, go one folder up, and then go down into the data folder, and then look up the pew.csv dataset. So if we look at the head of this dataset, this is exactly the same dataset shown in that paper. But you can see here is an example of a dataset that's not tidy. But it's really great in terms of something that you would show in a report. So for a given religion and a given income bracket, I think this is like the count of people. And so if we go back up into this paper, what is the problem? What are the three problems that we will cover? Column headers are values and not variable names. What does that mean? Well, if you look at our columns, you can see that we have a bunch of columns that are actually income brackets, and that really should be in one column that's called like income. And then on the right-hand side, we should probably have like a count column that's just for a given religion and income bracket, there's a count, right? All right, so how do we fix this type of problem? There is this notion of like long data and wide data. If you read the paper, that's also kind of ambiguous, but I still need to use it because that's how database people also talk about things. So you can think of long data as like a lot more rows since it's long versus wide data, which is just a bunch of columns, right? So in this case, this is an example of wide data because we have a bunch of columns that we really want into long format, right? So hopefully if I show you the code and run it, it'll make a little bit more sense. So if we are going from like wide data to long data, and this is the reason why the function is named this way, you can think about like if you have a sword and you're trying to melt the sword, it goes from wide to long. So the function that we're using is called melt. So Pandas has a function called melt because we're going from wide to long. And melt, if we look at the function signature, so if you hit Shift Tab, the first object is a data frame. And so the data frame we want to melt is called Pew or PEW. And then there's a bunch of other parameters in there. So one of those parameters is called ID_vars. And ID_vars, essentially what you are trying to do is you're trying to take a bunch of columns and turn them into one column, right? So you're going from wide to long. And ID_vars is essentially saying, hey, what are the column or columns that you don't want to touch? Right? And in this example, we want to leave the religion column alone. We actually want to melt down all of the other columns. So we can say something like ID_vars is religion, meaning that is the column that we don't want changed. So let me save that into a variable called pewLong. And if we look at it, we now took all of those columns that wasn't specified by ID_vars, so religion, and we converted them or made them long into a column by default. It's called variable and value. Right, so if I don't use head, hopefully this will show. You can see for a given religion, we have a income bracket and then like a count, right? And that is the tidy version of that data set, right? We have each column is a variable, so religion, in this case value, variable and value. Each row is now an observation. Say again? Oh. The index RD indice is unique. I believe the indices are unique. I have to I never actually ran into a situation where like I was playing with indices when I'm doing this, so I don't know the actual answer to your question. But hold on, let me see. Maybe there is. All right, so there isn't like a reset index. Yeah, I don't know. I might play around with it like afterwards. All right, so if we look at this, anything that you didn't specify in ID vars get thrown into this other parameter called value vars, right? So the function takes really two things, ID vars and value vars, and whatever you specify in value vars, if you leave ID vars alone, that will be in there and vice versa, right? So you don't have, whatever is easier or shorter to type, that's the one that you use. You can also use both of them if you're also trying to subset columns at the same time. But the other two parameters in here, var name and value name, that's how we change the default value, variable and value columns, right? So if we take the same exact piece of code and we say var name is now income, we can also say value name is, I think I have count. Now if we look at our data set, we actually get like some sensible variable names for us. Right? So yeah, so if you ever end up in a situation where you have a bunch of columns and you're like, hey, those are clearly like variables I want to put into a model, that's all you have to do is turn this, melt your data set, specify the columns you want fixed or the columns you want melted, and then you have your tidy data set, right? So now you can do something that's sort of like for a given religion, like predict the count or something. That's like probably a terrible model that you would want to fit, but that's something that you could do. All right, so what happens if we want to work with more columns? So there's another data set in the data sets. So there is a data set called billboard.csv. And this, we really have the same problem, we just have a lot more columns, right? So let's look at any individual row. We have a year, artist, track, time, date entered. So these are all songs in 2000. And then we have its billboard like rating from like week 1, I think it goes all the way out to like week 72. And so this is the same problem we had before, right? So what we really want is like a column called like week number. That's like week 1 all the way to 72, and then its actual rating. Right, so then you can do something like, you know, for a given week, predict like the actual value or something. So this is the same problem that we had before. We have a bunch of columns that are values instead of variables, right? So if we go back to the paper, we're still in this column headers are values, not variable names problem. This is just a bigger version of that problem. So how do we melt this? So we are using the same melt function. Right, whoops, melt. I will just be very generous with my line breaks so it doesn't flow off the screen. So the code is exactly the same as before, right? So if we want to melt a data set, the first thing we say is like, hey, what is the data set you want to melt? So the first parameter is going to be the data set. And then before, when we specified ID vars, we only put in religion, but in this case, we really want to hold on. We really want to hold year, artist, track, time, date entered like the same. Those are the columns we don't want to change, and then everything else we do. And so here, we could just put in year, artist, track, time, date, dot entered. Right? So these are the columns that we don't want, and then all of the others, which is week 1 to 72, those are the columns that are slated to be melted down. So we don't need to put in the value vars parameter in this case. And then just to round off the example, let's just have, when it does this, let's create like sensible names for these things. So we're gonna call the columns, those column names are now gonna be in one column called week. And then value name, we'll call that rating. Right? So now, if we look at our data set, we get year, artist, track, time, date entered for a given week, what is that song's rating, right? Why might you want to do something like this? Again, you can do this for modeling purposes. This is actually the definition of like tidy data. If you work with databases, databases prefer data in long format. So before you dump something into a database, you probably will end up doing something like this. I had this example where we had like this 1,000 by 1,000 row data set, and we tried to dump it into Postgres, and it really didn't like the fact that we were trying to put in a data set or a table that had 1,000 rows, 1,000 columns. And so what I had to do was actually turn this into like this many thousand row object with like 2 columns, and then it was fine, right? So different things need different forms, but if you're also thinking about databases, this is also the format databases prefer to do things in. All right. So remember shape, so billboard.shape. This billboard data set really originally had 317 rows and 81 columns. Uh-oh, what do I call this? Melt. Say again? Yeah. So I'll just talk what I just said. So if you look at the shape of the two data sets, you'll notice that one has way more rows than the other, right? Sometimes that's just what happens when you're trying to tidy data. You just end up with like, oh, I only had like 100 rows before, now I have 1,000,000. Well, it's really the same number of cells, but one is definitely more favorable in terms of a format for data storage and just modeling in general. All right. All right, so let's go. So that's usually the pd.melt. That's what you do when you have that first problem. Like I have a bunch of columns and I just want to melt it down. What happens if you have multiple variables stored in one column? The paper, we'll be using a different data set from the paper, so I just want to show you what the paper has. This comes from I think these are counts, TB counts. And you can look at, one, we actually have the same problem as before, right? Like these column names are actually values, and they actually store 2 bits of information, right? So the way we read this, M014, this stands for male 0 to 14. And then we have the same thing, and it goes all the way up to like male 65 and above. And then we have the same thing for female 0 to 14, et cetera, et cetera. Right, so we know the first problem is like we need to do something with melt, because what we would really want is a column that's like male and an age group, right? But the column name itself is storing 2 bits of information. So that's a problem. So how do we work with that? So in our data set, we have a, sorry, I will load this before all right. So here we have a data set called country time series. And so this is a data set for when I was just about to join grad school, I met with another graduate student in the same program I was going into. Her name was Caitlin Rivers. She currently works at Bloomberg School of Public Health, I believe, at Hopkins. And she curated this data set from the 2014 Ebola outbreak. So at the time, Ebola was like first big outbreak in West Africa. Countries were giving reports, and she was kind of reading those reports and just putting down these cases and death counts that the countries were reporting into a data set. There's a repository for all of this, and I'll link that as well. But you can see this data set has the same exact problem as before. We have cases Guinea, and then the number of cases. And if we scroll to the right, we also have something called deaths Guinea, and then the number of deaths, right? So what we would really want is like a column called date, a column called day, a column that somehow distinguishes whether this is a case count or a death count. We also want a column that is like the country that this is a count for, and then another column that is the actual count. right? So that's the end goal when that we want. So let us take a 5-minute break so we can like go to the bathroom, get water, et cetera, et cetera. So it is now 2:16. Let's come back at 2:21. Yes.
Can you slice on the melt index things so you don't have to like name them all in an array? Can you say like from this column to this column?
Yes, you have to write like weird code for it, but yeah, you could. You could totally slice columns without, but you have to write like other Python code to do that. Yeah. So let's come back at 2:20, and then we'll just pick up from there. All right, 2:20. That was actually really fast, I guess. All right, but we have a lot to cover, so let us keep going. So we have this data set, and what we want is, we wanted those specific columns: date, day, country, whether or not it's a case count or a def count, and then the actual value. This goes to 4 o'clock, right? All right, cool. All right. So we know the first thing that we want to do, right? We want, if we melted those columns down, that gets us part of the way there. All right, so let's do that first. Ebola long is going to be pd.melt, so that's exactly the same thing as before. And then ID vars, the columns that we want to hold the same, in this case is date, date, and day. All right, cool. So that gets us part of the way there. We have date, day, variable and value, those are the default names. And then the only problem here is this variable column now contains 2 bits of information, right? So that is we did the first part, and now let's work on the second part. So if we look at this, if I were to ask you like, hey, so there's like case counts, desk counts, and then a country, how would you split this if I were like, without programming in general, you might just say like, hey, if there's like a really convenient underscore there, if we just broke the column down by the underscore, the part to the left will be whether or not this is a case count, def count, and a part to the right, that'll be our country. So we will do exactly that. So just to step out of the data pandas world a little bit and back into pure regular Python, if we have the string cases underscore guinea, Python has a lot of string manipulation functions with it. One of them is called split. And by default, split will split on a space. But we can say like, hey, take this string and break it up by some other delimiter, right? This could be an underscore, this could be a word, this could be like whatever you want. And what comes back is a Python list, and then each element of the list, that's what the components after it's split was, right? So we need something like this in our, to work on our column. We want to be able to break our variable, in this case column, by cases and guinea on the underscore. So the way we do that we can assign a value. So the column that we're looking for is the variable column, right? So I didn't really give these any special names. So the variable column. And so the key part is there is this thing called an accessor called str. And this allows you to take a column and like do string things with it. So str stands for string. So now we can treat this column as a string, and now we've opened up a bunch of methods from Python that like work on strings. One of them, like I just showed you, was called split. And what we want to do is split on that underscore. So now if we look at variable split, so we took this column, right? So this column was this column over here. We accessed this column as if it was a string, so str, and then we ran the split method, and what we get back is this vector, or this column, of our string split into two components. So let's look at this a little bit. So what we get back is a series. So again, a series, if you see series, think of this as a column of data. If we, for example, this is a series, we don't need to use loc or iloc. It's just one vector. So we can just say, like, if we want the first element, we can just say bracket 0, and just to get the first element out, right? So this gets the first element out of a series. If we type this, notice that this is a regular Python list. So if we, from this list, if we wanted, because we know this is a Python list, forget about working in the Dataframe world, just think, how do I get things out of a list? We use square brackets, so if I wanted the first element, without using type for now, we can get cases by just pulling out the first element, and that type is just a regular Python string, right? So this is why, like, if you ever get confused, just run type off of everything, right? It'll help you contextualize, like, what your problem is. Right, so before it was just like, what the heck is this thing? I've never seen this before. It's a series, so forget about what's in there and just treat it as a series. And then you can slowly break down your problem that way. All right, so how do we get this all back into our working with our data? So the first column, or the first entity in this list, is what we want in terms of, like, status, we'll call it, cases or death. And then the second one is going to be country. So how do we, like, in one go, just get all of the first elements? So if we take variable split, so that's that. And if we say, I think if we just use 0, no. Hold on, yeah. So you can say, like, hey, treat this thing as a string, and then just get the first thing out of it. You can use .str, you can use that accessor again, and then put a bracket 0. I like to be a little bit more explicit and say use get, just so I can say, like, hey, treat this thing as a string, get things out, and then get the first element out. So, like, people have told me, like, how is this any different from using square bracket 0? There isn't really. I just like to use the word get. Just helps, for me, read a little nicer. So that's how we get that first column, right? So that's what we want. And then if we wanted to get the second element, we can just say get 1, and then we get the countries. So we can use those two components to break up that column. So the data set we've been working with this entire time was called Ebola long. And if you wanted to create a new column, just pretend that column always existed. So we can subset this column just like before, and we can say status is now equal to that thing, right? So remember, when we ran get, it gave us a vector back of whether this was a case count or a def count. And then we can copy and paste that column again, that line of code again, and we can say, we want another column called country, and that is the second element in that data set. And now, if we look at our data set, we took, with the code I just selected, broke up that original variable column, and we reassigned it to 2 new columns. And so if you ever end up in a situation where, like, you have columns both stored, like for a given column, it's storing 2 bits of information, what you end up having to do is a melt and then some kind of string manipulation to break this thing up. There's another, so that's like the very manual way of doing all of this. There's another way you can do this, like, essentially in one go, which I will show you. So if we go back and we look at the original command called split, split actually has a parameter called expand. And if we set it to true, instead of giving back a list, a vector of lists, it will just give us an actual data frame back, right? And you can see here, it gave us a data frame. It didn't know what to call these columns, so it just gave us 0 and 1. But this is something that we can work with. So if you really wanted to take that thing that I just showed you and do it in one go, you can do something like Ebola long. And also, remember when I said if you wanted to assign stuff to a column, make a new column, just pretend the thing always existed. So if you, again, remember selecting multiple columns in a data frame, you use 2 sets of square brackets. So if we just pretended that status expanded or country expanded, if we just pretend those columns always existed, we can assign columns that way all in one go. Right? One other thing that you'll see really often is if you have really long bits of code, the Python community tends to wrap that whole thing in a set of round brackets. So I put one here in Ebola long at the very end. And then in between, like where you have these dot notations, you can break up and create a new line. You'll see that very often in the Python documentation on like if code just starts to run off the screen. All right. Cool. All right, so we worked with the first 2 sets of data. So column headers are values, not names. Multiple variables stored in one column. What happens when variables are stored in both rows and columns? What does that look like? So we have a data set for that. All right, let's look at this data set called weather. So this data set, the first thing you'll notice that, okay, you have D1, D2, D3, blah, blah, blah. Okay, we're probably gonna melt something. That's something that we've seen already. But how do we know that a data set has essentially data like everywhere? One of the symptoms of something like this, if we look at these 2 columns right here, if you end up in a situation where pretty much the vast majority of this row is duplicated except for like one value, you probably have this problem where like data is being stored in, hold on, what was the symptom called? Variables are stored in both rows and columns. So if you have a row of data where a lot of information is repeated except for a few numbers, that's how you know that variables are actually being stored in a row. That's one of the symptoms. And so let's look at this data set. We have, I think, a temperature. I want to say this is in Fahrenheit. But I also don't know what country this is in, so this doesn't help. So we would really want like some ID, the year, the month, the day. So the day information is stored in columns. And then for this element, we want like a column that's like temperature max and then another column that's like temperature min, right? That's what we want at the end. But we have this problem where like, hey, this T min and T max stuff is actually in this column called element, right? So in reality, what we're trying to do is like, hey, I just spent all this time melting data. How do you do the opposite of melt, right? So what we really want is take this element column and actually pivot those values back up into columns themselves, individual columns. So we want a column called Tmax and a column called Tmin. What we don't want is a column called element where there are values for Tmin and Tmax. All right, so how do we fix this problem? Well, the first thing we've seen like over and over again, we have these days stored in columns. So let's fix that part first. So we'll be using this melt function again. So this is the 3rd time that we'll see this. So we pass in our weather data. And the columns that we want to hold consistent or not touch is the ID, the year, the month, and element. Let's actually give these things sensible names. So when we pivot this down, those D1, D2, D3, we'll just call this day. And then this value name, we will call temp for temperature. And I clearly spelled something wrong. This is great. Oh, okay, that's not too bad. Cool. Live coding is great. All right, so just like before, that got us part of the way there, right? So you can see here, this symptom is like even more pronounced, right? So we fixed the day being columns problem, but now we have like ID, year, month, day, temp, and like the only thing that's different is like whether or not this is a min temperature or max temperature, right? So like pretty much everything except for like one value is duplicated in this data set. And that's like the sign that like, hey, something's like a little weird. Another way you can think about like, hey, what is the problem now is like, hey, if you wanted to fit a model based off like year, month, and day, and you wanted temperature as your response, how would you like, you want like one of the predictors to be like the min or max temperature, right? Like you don't, this is actually like a terrible example. But you don't have any way to specify min temperature or max temperature. You just have this column called element, right? And that's not really being helpful. So if you think about it in the end, a lot of people want to end up fitting a model. So if you think about like how would you fit a model, that's another way to like diagnose like what your current problem is. All right, so what is the next part? The next part uses this function called pivot. I use pivot table, but the example will show you pivot table, but I want to just show you that like there's two things going on. So you could, in this example, you could also use the method or function pivot. The difference between pivot and pivot table is you can, for example, let's just look at the first two rows. Let's say I am like a researcher and I'm like out in the Arctic and I'm just taking temperature readings. In this example, I have one temperature for min and one temperature for max. But let's say I like have another collaborator that's also taking temperature readings. That's going to have the same year, month, and day, and he's going to have another set of temperature min and max values, right? So now you can think like for a given year, month, and day, I have duplicate values for a specific temperature. If you use pivot, the function, it doesn't know how to handle duplicate values, right? So for 2010, January 1st, the maximum temperature, well, it's missing, but let's say that there were two values for that. When I do a pivot, like just like in Excel, when you do a pivot table, it doesn't know what to do with like, I can't handle multiple values, right? So in Excel, when you do a pivot table, I think like by default, it takes like the mean or something. And so that's what pivot table will give you, is you get to specify here an aggregation function. So you can say like, hey, I want the sum, I want the mean, I want the min, I want the max, et cetera, et cetera. So those are the subtle differences between pivot and pivot table. In this case, I'll just show you pivot table, but just know that like if you're using pivot, you're making an assumption that like there are no duplicates. If there are duplicates, your code's gonna crash. It's gonna throw an error. So how do we work with this function? So the newer version of Pandas actually had like a small API change. So before I've been using pd.melt this entire time. You could have very easily have used weather.melt and called the data frame directly, and it would have done the same thing. That was one minor change. So you can use pd.melt or right? They both call the same exact code. And the reason why I bring that up is because the pivot table function used to only work on weather.pivot, weather long melt. Pivot table used to only exist as a data frame method, and so like people are like, why do I have to use pd.melt in one case and then dataframe.pivot table in the other case? So they sort of like unified the interface that way, so you can use dataframe.melt or pd.melt in both cases. All right, so how does this pivot table function work? We pass in, actually it's just way easier for me to explain it. So just like before we had like index vars or ID vars, here we specify, hey, what are the columns that we don't want to move? So we don't want to move So we have to use a Python list because we're using multiple columns. We don't want to move ID. We don't want to move year. We want to keep month the same, and then day the same. What in the columns parameter, what is the column that we actually want to do this pivot? So here we are saying pivot this element column. So what it's going to do is it's going to look at this element column. For each unique value in this column, it's going to create a totally separate column. So that's the element column. And when we do this pivot, we now have to say like, hey, we just created, in this case, 2 new columns. What are the values that we put in when we do this manipulation? So then we pass in this values parameter, and we just say, hey, use this temp column here for temperature, and use that to populate after we do this manipulation. So now if we look at this, we get what we need. It just prints out like a little wonky. So we have now a column called ID, column called year, column called month and day, and then we also have a temperature max and temperature min. Depending on what version of Pandas you're using, I think there's also a parameter in here called drop NA, so this will drop missing values. So that's why you don't have a bunch of NAs for example, January. It's only showing D30. Depending on what value of Pandas, you might just have all of them as missing. All right, so you have this data set, and this is almost exactly what we want, but it's just printing out differently. One of the sort of tricks that I do is like, this is a hierarchical index. It's like there's a hierarchy in the columns and rows going on here. So I also, in my day-to-day, I jump for like any given hour or day of the week. I'm either using R or Python, so I try to just bring everything down to like the lowest common denominator. And so I just want to work with like a regular flat data frame, right? So the way we do that is there is this method called reset index. And if you run reset index and you have this weird hierarchy thing going on, and you know it's a weird hierarchy thing just by the way it's printed, right? Like, if you ever have that and you're just like, okay, if I pretend to treat this as a data frame, it'll work for most time, but like there's some weird edge case. There's some weird edge cases going on. But if you just want like a regular flat data frame, just run reset index and it'll just flatten everything down for you. And sometimes you have to run reset index like twice, so I wouldn't worry too much about that. All right, and now we have like a nice tidy data frame for our weather data set. All right, last part. What do we do when multiple tables, multiple types of observational units are stored in the same table? So, an example of that was our billboard data set. If you think about like how databases work, or if you like work with databases, or if you are a database administrator, and if we looked at the tidy version of our data set, of our billboard data set, you can see like year, artist, track, time, date entered. Like there are 72 weeks, like for any given song, there's like 72 rows of information, right? This stuff that I have highlighted is repeated 72 times. And so if you think of it in terms of like just data storage, like this is now leaving the realm of like working with data for like modeling purposes, because this is the format that you need for modeling. But if you're thinking about just storing data, you have this stuff here repeated 72 times, right? Like that could get really bad very quickly. And so let's look at, for example, let's look at this data set such that the track is the song Loser, L, right? Like this song by Three Doors Down is repeated in our data set a bunch of times, 76 times in fact, right? So that's not good. So how do we kind of fix this stuff up so like our data sets are a little bit more like storage and database person friendly? I showed you guys how to filter your data set, so it's really just a combination of like filtering your data set with like drop duplicates, right? So let us take our So we want to create like a songs data set, which just holds information about our songs. So how do we do that? Well, that's our Billboard melt. And what's information stored in songs? It's just year, artist, track, time. I'll leave the date entered like separate, but it's fine. Right, so we have our Billboard songs, right? So this is the stuff that was like repeated like 76 times, right? So if we look at our shape, we have like 24,000 rows in this. But if we run this command called drop duplicates, it'll return back another data frame such that all of the duplicate rows are no longer there. So let's reassign this back to our data set. And now if we look at shape, it's really like 317, right? So you can clearly see like we went from 20,000 to 317, and this just for data storage, like this could save you a bunch of time. All right, so if you think about, I didn't talk about merging data sets together or anything, but if you think about like, hey, I have a songs data set, that's great, and I'm gonna eventually create like a ratings data set, that's great. How do I combine those two data sets together? Like how do I join those two tables? If you know anything about joining tables, you need like an actual key. So let's generate a key. So how do we generate a key? Well, one way is really to say we're going to make a new column called ID. So every song will have an ID in our data set. And we can use this Python function called range, and we can say, hey, generate an ID, and it's based off of how many rows are in our song data set. So what does this look like? It creates a column called ID, so that's what's going on here. Range is a function in Python that just, you give it a number and it'll generate a value. It's really a generator, but think of it as a list from 0 to that number, right? So it created 0 to 316 for our 317 songs, right? So that just created our ID for us. And if we want now, if we really want, you can say songs to CSV, and you can save this. So billboard songs.csv. What you want to do when you save this stuff, there is a parameter called index. Set it to false. Otherwise, you get this nameless column in your data set, which you probably don't need, or we're not using an index in this case, so we don't need it. And that's how you save out your songs data set. All right, you're using this to_CSV, save out your songs data set. So now we kind of need to backtrack a little bit and get another totally separate data set that is like, for a given song ID, what is their week and rank for that week. So we need to go back a little bit, and we need to join these two tables together. So we eventually want to create a data set called Billboard Ratings. And we're going to take our original full data set before we filtered our songs out. And what we're going to do is merge these two tables together, the songs table and the original one. Why? Why do we want to do this? It's because we actually need this ID column that we just created, right? Otherwise, we just have like this ID column with this songs data set that we can't really do anything with. So we're going to do a merge, and the data set, okay, I'm pretty sure I can just do this on the fly. Uh-oh. My notes. All right. So the data set that we want to merge is this songs data set. In merge, so you can see we have literally the left data set is, if you read your code from left to right, what is the data frame that shows up on first? So left will be Billboard Melt, right will be Billboard Songs, that's what we just provided. How by default is inner, meaning that only the tables that found matches will be returned back. You can do left, right, inner, outer, et cetera, et cetera. If you want, there is a column called on. So both tables have the same exact column names, you can use on equals. If the column names or on the left data frame are not the same as the column name on the right, you can say left on, right on. In this example, our columns names are the same, so we can just say on, and we can say we are merging on, year, artist, track, and time. Now, if we look at Billboard ratings, all we did was like a really fancy way of like getting this one column, this ID column. But that's good because now we have like for ID 0, which is this Tupac song. If we go back, you can see that ID 0 is just this song by Tupac. So now that we have our ratings or the ID part there, we do the same thing that we did with songs, which is filter the columns that we want, drop duplicates, and then we can save that out. So ratings is Billboard ratings, and what are the columns that we care about? The columns we cared about in this case is ID, date, entered, and then week, and then rating. Right? So just like before when I showed you or at the very beginning, all we're doing is filtering our columns, and that's all we did. Say again? The IDs aren't all 0, it just so happens to be 0. So let me just say, like, sample. I think this works. Yeah, if I kind of just take a random sample of this, you can see like the IDs are actually different. And like these ID numbers now, if we want, we can go back to our songs data set, look up an ID, and we'll actually know what song it is. And then that's it. If you want, you could drop duplicates. I very much doubt that there are duplicates in this example. But if we want, we can then say to CSV, save this out to billboard ratings.csv, set index equals to false, and then we'll have our 2 data sets. If we look at info, ratings, songs, and then I think it was just sort of the order is messed up. But if we look at info, one of the things down here is like the actual memory usage of this data frame. And so if you look at our original data frame, we have like 1.3 plus megabytes. If we look at the separate ones, they are actually much smaller in terms of data set size, right? So again, the last point of tidy data is more for data storage. If you're actually gonna combine data or fit a model or something, what you're doing is like combining and doing the merge together and getting the full 1.3 megabyte data set loaded in memory. But in terms of storage, this is way easier to store, right? Like you've cleaned your data set up, break it up into separate pieces just so if you have to zip this up and email it to someone, or if you're at a conference and the Wi-Fi is really bad, this stuff just downloads faster. And then, part of your data process is assembling and combining the data sets that you need for analysis. Right, so that is, if we go back to this paper, that is all 5 points of this paper, right? Column headers are values, not variable names. That's essentially just melt the thing. Variables being stored in multiple places as really some kind of melt and then some string manipulation or some kind of string processing. That's usually the general workflow going on there. Variables being stored in both rows and columns, well, you treat that into really 2 separate pieces. Treat it as variables being stored in columns, so that's a melt. And then whatever you need, you pivot back up, so the opposite of melt. And then the last 2, the technical term is called normalization. So you're normalizing your data, break information up into as many like logical pieces. Make your database person happy. Databases themselves will be happier. And then what you do is like this combination of joins when you're ready to like work with your data sets. This way, someone doesn't have to load up like this massive thing if they actually care about like those 2 other components versus the 2 that you already have combined together. And then the last one was like a single observational unit stored in multiple tables. So that is essentially when our billboard data set that we had originally, that is this last problem, right? So when you're ready to do your analysis, you're kind of like not making your data adhere to the last point because you're actually combining your data sets together because this data set now contains song data and rating data, but that's what you need for your analysis. So that is it. I am on time. So if you guys have any questions, there's microphones, people running around, but hopefully that gives you the big intro into pandas. And this was sort of just like show you how to work with pandas, load stuff up, load a data set, subset stuff, and then we get to like, I really like talking about this paper because my job is like processing and cleaning data. So this is a pretty good paper just about what does it mean for data to be clean. And if you end up like learning or having to learn another language, this way, this paper or just thinking about how to clean and tidy your data, that is a pretty good way to like learn another language because you don't care about like what is the function called. You just need to know, I need to do this step. How do I do a melt in R, right? So that makes stuff a lot easier. So the question is about like how do you change stuff and make it look like R? In general, I think that's like what you're trying to reach. Hold on, I'm trying to find like the example of code that was, all right, here it is. All right, so there's like two different, like R and Python, they're really like fundamentally like very different programs in the way that they're handled. Like R is functional, very functional, and Python's very object oriented. And so how do you make your code like look like it's chaining together is first you wrap like your commands around round brackets. And what ends up being the result of this stuff is like, what is the type of this? Well, that's just a regular data frame, right? So you can treat all this code here as a regular data frame. And so if I wanted to, so in this example, what I ended up having to do was also like run the reset index to reset this thing together. So how would you actually chain this? Well, you literally say like reset index because a data frame itself knows how to reset an index. So that is the closest to like chaining there is in pandas. So if you also want, I think like, this is like, I think it's called select. Oh, geez, that could be. Yeah, so if you wanted to, you can also use this method called select to like filter rows and columns, right? So then you'll end up doing something like this, dot select, dot something, dot something. So that's the Pandas Python way of chaining things together. Just in general, so teach a man how to fish. In the Python Pandas documentation, there is a bunch of stuff in here, but there is this other section called API reference on the bottom. And this is like everything there is to know, like all of the functions available to you in pandas. So for example, I showed you guys the s.str accessor. And so in here, if you were to look up str.split, that's how you find like the definition for split, right? So if you're curious, you can also look up like what can a data frame do? So if you end up on the page of like what is a pandas data frame, you scroll down a little bit, you can see all of the attributes a data frame has. So like T if you just need to transpose, so it's dot capital T. I showed you .ix, .loc, .shape, but then you have all of the methods down here, right? So like melt, reset index, et cetera, et cetera. All of that stuff is here. And this is all the stuff a data frame can do. And if you can find what a data frame can do, then you can just dot chain them together. And that's the equivalent of chaining in R. Cool. Oh, one more.
I have a question to sort of follow up on that question. Curious if you, in your shop, if you've seen or you use a preference or best practice around working in pandas if you know that you want to index particular columns, but you also do a lot of chaining for readability, if there's a preference or best practice around accessing with brackets versus the dot notation, if you know you're going to be chaining extensively.
I don't know if there's like an actual best practice. I use a square bracket notation a lot. That's just how like my R scripts look like that. I wouldn't say there is like a best practice really. What ends up really happening, at least this is like me speaking for myself, is like you'll write a bunch of code just to make stuff work, and then like hopefully you go back and like clean up your code later. If this is one giant like data processing pipeline, you might want to just end up writing everything in a dot notation just so it looks a little clearer. But in terms of like how do you like run your script, or like write it originally from the beginning, I just write it like if I'm assigning a new column, I'll just write, square bracket new column equals this other thing. I haven't really written my stuff into using this chaining notation very often, other than like, if I'm running like a group by, that's usually where you'll see a lot of chaining where like Dataframe group by this, select these columns, and then plot this thing. Like, so when I write my code, like the chaining stuff ends up being like pretty. Like this is actually trying to do one thing. I'm not trying to like run my entire data analysis pipeline in chaining, mainly because if something goes wrong, you have to unchain the whole thing. And so sometimes I just write things like, if it goes wrong, at least like I don't have to like undo like 50 lines of code. So, but yeah. And then you might end up in a situation where like some things like a data frame just doesn't have a method for already. So like you just can't chain it. So. But yeah, okay, so that's time, I believe. I'll be around today and also around the conference the next 2 days, so if you want to say hello. Hopefully tomorrow, I have a big stack of books that I will be giving away, so hopefully you guys win one, find me, yeah.